In this video for the KCAD Digital Art and Design Augmented Reality Framework, I'm going to go through how to properly set up the image target. An image target is the image that you'll print out, and then the application will recognize through the device's camera as an augmented reality target, and will then place the video on top of the image and track along with it. So if we take a look at our KCAD AR framework folder, we can see the image that's used in the example. If we go into the web folder, examples, and then print, there's this image.png. And here is the image of KCAD here that you could print out to test the example for yourself. But the image that is actually used in the application has to be run through a process according to the AR framework. So if we look in the actual AR image video example folder inside of assets, here is our video, but then underneath it is our targets.mind file. That's from Mind AR, targets.mind file. And this is a web-based process that we can go here to the Mind AR documentation, and you can see the URL up here, hiuk.mind-ar-js-doc/tools/compile. And this is the image targets compiler, where we can add regular PNG or JPEG images and create a target. Now there are certainly rules for what makes a good versus a not so good image for image targets. So we'll go through a couple of the basics here in the video. This is a 4-part article that is created by the Mind AR Augmented Reality Framework author. And the first part just introduces the series, so the second part begins to go through the information. And we'll just breeze through this second part for now. It goes through and talks in a technical way about how these different feature points are recognized throughout an image, and talks a little bit about different ways that it can match feature points within images. Use a real-world example, shows all the different feature points that can be pulled off of this image. And if we skip right ahead to part 3, has all of the summary from the previous part right here. It basically explains that it's good to have good feature points that are distinguishable, a lot of good feature points together. The image as a whole can be located, a lot of good and well-distributed feature points to make it error tolerant. So a general rule of thumb is any image to be used as an image target should have some level of detail to it. The more detail and the more unique, the better. So some specific characteristics in part 3 here. Here's kind of the level of detail, simple versus complex. Complex is more of what you would want. You don't want necessarily symmetrical or repeating patterns. This would be better over here on the right. Not a lot of big blank spaces. You want more detail, so more feature points can be found distributed throughout the image, and then high contrast. There are a couple of characteristics that don't really matter, such as color. It's generally useless to make it colorful. They don't really worry about color, finding the different feature points and tracking points. And also gradients. Only sharp changes matter. So something like this, a gradient sky, might seem like it might have a lot of detail, but it might not be a very good use as an image target. Resolution, as long as it's at least around 1,000 pixels, it should be good enough to be used as an image target. So you don't want it to be too small, but anything larger than that, you don't need to get too detailed. The aspect ratio doesn't matter a whole lot. There's some use cases it talks about here in the article. And then it talks a little bit about just being aware of your actual target placement, where it's going to be on a product, on a printout, on a wall, something like that. So the fourth part just kind of summarizes the whole thing. That's really the gist of it. So go ahead and go back to the compiler, and I'll show you the process here. So we actually add, so we can drop files to upload. Let's go in and go back into our print, and I'll just show you the process when we drag the image.png here I wanted to use onto this. And as you can see, it adds a thumbnail. Go ahead and click Start. And within a couple of seconds, gave us a little percentage progress meter. We can see all of these little red circles representing the feature points. And I could download the compiled file. We'll go ahead and do that. And it downloads this targets.mind file, which is the same. We'll come take a look at these other tabs in a moment and see what that is. I go back to the Finder. I can see that in my downloads, downloaded this targets.mind file, and it's the exact same file that's found in our assets in our example here. So it's as easy as that, just importing a regular image and running it through this process and then downloading it from here to get the mind file. Take a look at these different scales. Okay, I see. So it's taking our regular resolution image and it's automatically giving us different scaled versions of it that we could use if we wanted. So that's a nice helpful part of that tool too. I assume downloading them, or actually, now that I think about it, those wouldn't be different things. All 8 of those scales are probably combined in the same MIND file, and that's how it helps track it as you get further away. So that's really interesting to see how that's put together. All right, well, in our next video, we will take a look at considerations for preparing your video asset.